and this is
And
this is our design. It's an analog multimeter. Our multimeter is made up of resistors, a coil, and magnets, which are our main components of this multimeter.
our analog multimeter is able to measure voltage and current, and those two can be used to calculate resistance and power, which means our requirements.
Now we want to measure the current. As you can see, everything now is on zero. Now we're moving from 0 to 5, 0.5, 0.5 amperes, and then it's 1 amperes now, 1.5 amperes, and as you can see, and everything is in order now it's back to zero. Thank you.
In the first part, we're measuring the current, and you can see we're connecting these two thick coils. So now, when you're measuring the voltage, you're going to use the thin coil, and you can see here. Okay, let me just disconnect the current ones.
Para grande mesmo,
Okay, you can see now that we have connected the thin coils. Okay, in order for us to measure the voltage, then the current should be maximum, as you can see. Then you start from 0 to 10. You can see it's moving. No,
we found out to make a multimeter. But however, the first one we found was that we use the digital one, which didn't meet our requirements, and the other one was a multimeter which used copper coil and magnets, which where the copper coil created an electric field, which moved the magnet, which moved the pointer to show us the voltage being used.
Upon testing of our first model, we found that our coil were overheating. So we decided to include the resistors in here in this circuit in order to move the heat from the coils to the resistors. So this was due to no load in the circuit, which is short circuiting, and the current was at maximum. So in order to have the normal current, we need to include the load in our circuit.
Right.
Yeah, so you can see the our needle. So most needles are using a spring in order for them to, after reading for it to go back to 0, it needs a spring. But us, we used a torque force. Like you can see, we use the magnets here. So the weight here of the magnets forces the needle to go back to 0.
According to us, our final solution, we consider it to be good, because the error that may occur in the multimeter are the errors that might occur while the multimeter is being used are addressed, and for example, overheating and ensuring that the needle always goes back to 0 after measuring is being disconnected. Being disconnected. Our solution is simple because it can be easily traced and fixed due to simple circuits. As we said about the overheating part, if it happens that the circuit overheats, only the resistors will burn out, and which can be easily replaced, unlike having the coil burn out.